Hello, everyone. Welcome to Ethics Grand Rounds. I'm Deborah DeBruin. I direct the Center for Bioethics at the University of Minnesota, and I'm delighted today to be welcoming Dr. Lara Cushing to be talking with us about environmental justice and health equity. Before I introduce Dr. Cushing, we'll talk through some logistical matters for today's talk. Next slide, please. So can we go back a slide, Andrea? Thank. As the slides are going back up, I'll just begin. So for questions today, please use the Q&A function, which you'll find at the bottom of your screen. The Q&A function is really your one-stop shop for communications with us today. So if you have a technical issue, for example, feel free to ask your question in the Q&A, and center staff will assist you with that privately. If you have a question for the speaker, also please put that into the Q&A. You can type those questions in at any time during the talk, although we'll hold off on answering questions for the speaker until after she's finished with her presentation for today. We're not able to manage use of the raise your hand function. So again, please just use the Q&A function for all of your communications with us. This webinar is being recorded, and the recording will be accessible on the center's website and on our YouTube page after the event is over. We've enabled captioning for this webinar. If you would like to view captioning, please go to the bottom of your screen, click Captions, and then Show Captions, and they should appear for you. If not, please just raise the question with center staff in the Q&A, and they'll work to assist you. We would ask that you complete, if you would, an evaluation of this event. We're going to try to make it very easily accessible for you, easy for you to do, because we take your feedback on these webinars very seriously. So you'll get access to the evaluation in 3 different ways. First, it'll just pop up automatically into your web browser as the Zoom is closing after the event. If it's convenient for you to fill it out right away, please do. If not, there are other ways that you can access it later. The evaluation is also linked in the presentation details document, which will be available in the chat in today's event. That presentation details document is the site of a lot of the information you will need for today. So I can see that center staff has linked it in the chat now. Feel free to take a look at it for information like the evaluation. Also, you'll receive an email after the event with a link to complete the evaluation. Next slide, please. There are a number of ways you can get credit for attending today's event. If you would like a certificate of attendance for continuing ed credits, please complete the form that's linked in that presentation details document. For health professions students here at the University of Minnesota, this webinar has been approved for interprofessional education credit. If you would like to get IPE credit for attendance at this webinar, please complete the reflection form that's linked in the presentation details document after the event is finished today. Biomedical engineering students, if you would like to get credit for attendance at today's webinar, please go to the Canvas site for your course and submit the event name and date in the Bioethics Grand Rounds attendance section of the course. And then we'll work to make sure that you can get credit for your attendance today. Next slide, please. I'd like to thank the co-sponsors today. We work with many partners across the university to bring these events to you, and I am really grateful for their partnership. Our co-sponsor partners for this event are the Center for Anti-Racism Research for Health Equity in the School of Public Health, the Center for Race, Indigeneity, Disability, Gender, and Sexuality Studies in the College of Liberal Arts, the College of Pharmacy, the Center for Global Health and Social Responsibility, which is an Office of Academic Clinical Affairs unit, the Center on Science, Technology, and Environmental Policy at the Humphrey School of Public Affairs, the Medical School, and the Program in Health Disparities Research in the Medical School, the School of Dentistry, the School of Nursing, the School of Public Health, the Institute on the Environment, and the University of Minnesota Climate Adaptation Partnership. Again, thanks to all of those co-sponsors. So, without further ado, I would like to introduce Dr. Lara Cushing. I'll just do a brief introduction. I would really encourage you to review her very impressive bio, which you'll find in the presentation details document, but we would use up much of her time if I were to enumerate all of the wonderful things about Dr. Cushing. So I'll just do a very short bio or introduction. Dr. Lara Cushing is Assistant Professor of Environmental Health Sciences and the Jonathan and Karen Fielding Presidential Chair in Health Equity at the University of California, Los Angeles. She was a contributing author to the 4th assessment report of the UN Intergovernmental Panel on Climate Change and has earned a number of honors and awards. Without further ado, I will turn it over to you, Dr. Cushing. Thank you so much for joining us today to talk about this critically important topic.
Thank you so much, Dr. De Bruin, for the kind introduction, and to everyone tuning in today for the opportunity to share a little bit about my work. Hold on, I think I'm sharing the wrong screen. Let me try that again. There we go. So I'll be speaking about social inequality and the environment, and begin by describing the overarching environmental health disparities framework that is used to understand the disproportionate health impact that pollutant exposures have on marginalized communities. And then I'll share 3 examples of policy tools, decision support tools that I have helped develop in an effort to move from science to action that advances environmental justice and health equity. Before I proceed, can I just get a confirmation that I'm showing the correct slide deck?
It looks perfect to me, Dr.
Okay,
Cushing.
great. I always get confused with the 2 screens. Okay, so as an environmental health scientist who often collaborates with communities in research, one of the most common questions you'll get is something like this: how does the factory next door affect my health, right? A very understandable question. And you can substitute different environmental health hazards for the word factory in this sentence. Could be oil rigs, as pictured on the left in the Inglewood oil field, one of the largest urban oil fields in the country, which is located here in Los Angeles and where I'm involved in a community health assessment currently. It could be agricultural sources of pesticides in drinking water in the San Joaquin Valley of California, pictured here in the middle. Or a community member on the right who's holding a map of a shallow groundwater plume of carcinogenic solvents emanating from a former military base in San Antonio, Texas. So the traditional way to answer this question in my field is to use what's called the exposure disease paradigm. And I'm showing a very simplified version here. Essentially, this approach does is to consider how a chemical, usually a single chemical is considered at a time, how much of it is released from a pollutant source, and then what happens to it as it moves through the environment. Is it ingested or inhaled by people? What happens to it once it's inside our bodies? And what sort of health effect may result, if any, among people that are exposed? However, environmental justice advocates have challenged this framework and called on us as environmental health scientists to think about how social inequality interacts with this process to produce health disparities. And to do that, we really need to think about not just individual pollutants in isolation, but rather the confluence of multiple environmental health hazards that people are exposed to at once. Because systems of inequality have created uneven geographies of risk where multiple pollutant sources tend to cluster in space and in socially marginalized communities. We also need to think about the fact that those same communities are often simultaneously subject to chronic social stressors to health, including things like higher rates of poverty, unemployment, poorer housing quality, which can actually increase your susceptibility to pollutant exposures and worsen the health effects. So this framework argues that in order to understand health disparities, by which I mean preventable health burdens that adversely affect socially disadvantaged or marginalized populations, we have to consider the cumulative impacts of both environmental and social stressors to health. And this approach highlights the idea of a double whammy or double jeopardy, if you will, of environmental injustice. That as a result of racist policies, communities that experience higher exposure to environmental hazards also tend to have the least resources to cope with those exposures because they're more likely, as I said, to experience social stressors to health or some of the adverse social determinants of health. And it's this combination that contributes to the disparities we see in terms of mortality and morbidity. A large body of scientific scholarship has now consistently demonstrated what environmental justice advocates have been protesting for years, and that is environmental racism, a term coined by Reverend Ben Chavez, pictured here during protests of a hazardous waste landfill siting in Warren County, North Carolina in the 1980s. And this evidence consistently shows that not only are people of color more likely than white people in the United States to live near hazardous waste treatment and disposal facilities like the one protested in this photo, but also to live near a coal-fired power plant, a concentrated animal feeding operation, to live in a chemical disaster vulnerability zone, and in general to breathe dirtier air, drink dirtier water, and have less access to environmental amenities like green space in their neighborhood. This is an example from my own work in California, where we looked at 11 indicators of residential proximity to different environmental hazards with respect to the racial and ethnic composition of all zip codes in the state. So on the left, this graph shows all zip codes in California, and they've been ordered from left to right in terms of the proportion of their population that self-identifies as non-Hispanic white, as opposed to another racial or ethnic group. So if environmental hazards were evenly distributed with respect to race, all of the lines on this graph would fall close to the blue line, the line of equality. But instead, what you see that every indicator we looked at fell above the blue line. And what that means is that zip codes with higher proportions of people of color host a disproportionate share of these hazards. So for example, if you focus on the red or orange dot with the arrow, which is halfway across the x-axis, this point indicates the 50% of zip codes with the highest percentage of residents of color. And those zip codes host 75 to 80% of agricultural pesticide use in the state, cleanup sites, and particulate air pollution from diesel vehicles. And the pattern is not explained by racial disparities in income, because on the right-hand side, we've reshuffled the zip codes and have now ordered them in order of income, with the lowest income zip codes on the left and the highest income on the right. And here the pattern's much less consistent. Some lines fall below instead of above the blue line of equality, indicating that the racial disparities we see so clearly on the left are not accounted for by differences in income. So that's a bit about this concept of multiple environmental hazards and how they are clustered and people are co-exposed to multiple of them. Let me now talk about the bottom bubble from that environmental health disparities framework to talk about how inequality can get under the skin to actually worsen our susceptibility to environmental hazards. And this, concept is part of a hypothesis first put forward by Arlene Geronimus about weathering. And we since understand more about the biological mechanisms that link chronic stress response with physiological wear and tear on body systems. And those have been pretty well established. So, the concentration of poverty and other social stressors in disadvantaged or marginalized neighborhoods can affect coping capacity by limiting access to health promoting resources, also influencing health behaviors, contributing to perhaps maladaptive coping behaviors. And then the second piece about weathering, relates to the fact that chronic exposure to psychosocial stressors, things like financial and housing insecurity, experiences of discrimination, witnessing violence, these can lead to long-term alterations in the immune, neuroendocrine, and metabolic functioning of our bodies. A concept known as weathering, or also referred to as allostatic load, that really erodes the body's resilience and ability to eliminate and heal from the impacts of pollutant exposures. So how did we get here? What accounts for these racial disparities in environmental health exposures? So I'll touch on just one of many structural determinants of disparities and racial residential segregation that we see across US cities. And that's redlining, which refers to the denial of financial services based on discriminatory criteria, including race. The term stems from the red color given to neighborhoods deemed risky for investment in federal maps produced in the 1930s during the New Deal. The purpose of these maps, and I'm showing two examples from Los Angeles, produced by the Homeowners Loan Corporation, a federal agency. And their purpose was to make refinancing assistance more available in order to prevent foreclosures in the wake of the Great Depression. And they were created via a now infamous nationwide effort to appraise the investment worth of neighborhoods, and in partnership with local real estate and financial professionals. And they were published in these color-coded maps of perceived lending risk that assigned grades from green, A, to D, red, with D being quote unquote hazardous for investment, and colored red on the maps. So while it's debated how much these actual maps influence lending decisions, it's clear that they reflect and codified segregationist and racist sentiments in the housing industry that considered the worth of a house was very much tied to who lived in it, right? So with the lenders underinvesting in integrated neighborhoods and instead channeling credit towards white neighborhoods backed by racially restrictive covenants. Sorry, struggling with my notes here. So let me show you an example. This is really reflected in the appraiser notes that accompany the map, which have been digitized and made much more easily accessible by the Mapping Inequality Project at the University of Richmond. So again, these notes, they show the role that race played when designating the grades. So for example, when these maps were made in Los Angeles, the city had just experienced an oil boom and grown into the country's 5th largest city and one of the most segregated. And as Daniel Cummings shows in an excellent paper entitled Black Gold, White Power, appraisers considered oil development a detriment to property values and investment risk because of the health hazards posed by oil development. This is a photo you can see, the oil derricks right next to people's homes that had sprung up across the city. However, appraisers only considered oil development a detriment when combined with the presence of people of color. So circled here is the neighborhood of Wilmington, which was described by the appraisers as being literally engulfed by oil wells, but also they mentioned the infiltration of subversive elements that made future residential desirability, quote unquote, non-existent. And as a result, gave this neighborhood a grade of D. And by subversive elements, that's code language for immigrants and people of color. In contrast, El Segundo, which was literally a company town founded by Standard Oil, was given a grade of C because deed restrictions were in place preventing the sale of homes to non-white families. So again, the appraisers noted the derogatory influence of oil wells, refineries, and tank farms, but the deed restrictions they noted provided protection against quote unquote racial hazards. And today, Wilmington is a low and middle income, primarily Hispanic or Latino neighborhood that hosts multiple refineries and hundreds of oil wells, while El Segundo is predominantly white and relatively high income compared to the rest of the county. Looking nationally, this analysis by David Gonzalez and colleagues reveals that oil wells continue to be disproportionately cited in neighborhoods that were previously redlined. And we have shown in my own work the same thing with respect to the citing of fossil fuel power plants. Sorry, I went through that previous slide pretty quickly, but the graph on this slide is much the same. So let me take a moment to explain it, which just shows that the number of Hulk graded neighborhoods that have a fossil fuel power plant upwind and within 5 kilometers increases as you go from A, the most desirable grade, to D, the least desirable grade on these redlining maps. And we show in this paper that even nearly a century after the maps were published and half a century after redlining was outlawed in the United States, the color on those maps continues to predict the likelihood that a fossil fuel power plant is built near your home, even for plants built after the year 2000. And as a result, historically redlined neighborhoods are today still subject to higher power plant air pollutant emissions upwind of their neighborhoods. In a recent review paper on the impacts of redlining, we found over 24 studies that have shown the practice, or again, these Hulk grades were associated with adverse environmental conditions and health conditions across a wide range of outcomes as listed here. And many studies found a gradient of outcomes becoming poorer as you move from A to B, B to C, and C to D grades, indicative of a kind of dose-response relationship. So we provide a conceptual framework in this paper for understanding how redlining contributes to these present-day disparities. And I just wanted to mention briefly that, climate change is likely to exacerbate environmental health disparities. Of course, climate change affects all of us, everyone. We share the same planet, but not to the same degree, because your vulnerability really depends on your resources to mitigate and cope with climate extremes. So one example is extreme heat waves, which have been linked to the higher risk of preterm birth. And people of color are more likely to live in neighborhoods that you might consider high risk during a heat event because they have less trees and more heat trapping impervious surfaces, especially in the more segregated US cities. And so that means these neighborhoods are hotter on average during extreme weather events. And in an analysis of an extreme heat event in Texas, we showed that the effect of extreme heat exposure on preterm birth is stronger in neighborhoods where a larger proportion of the population identifies as a person of color and living below the poverty line. We, of course, have already very stark racial disparities in preterm birth rates. So this suggests that climate change, because it's increasing the frequency and severity of heat waves, might further contribute to the widening of that gap. In another recent literature review, we concluded that the vast majority of epidemiological studies that have looked at the question of racial disparities have found evidence that people of color experience more severe health outcomes during extreme weather events, such as hurricanes, floods, heat waves, wildfires, all of which are becoming more frequent and severe due to climate change. And this map shows you where those studies have been conducted and where the evidence of racial disparities has been documented in the United States. So how do we begin to address this legacy of environmental racism? Research is slow, but communities want and deserve action now. So how can we leverage the scientific evidence that we do have to facilitate timely interventions, inform decision-making? So I'm going to share a couple of three online mapping tools that I helped develop with the intention of highlighting communities of potential regulatory concern in order to help target holistic interventions that prevent harmful exposures and hopefully advance environmental justice in the future. These are the three tools I'm going to describe. The first is Cal EnviroScreen, which is produced by the California Environmental Protection Agency. It's a geographic screening tool that integrates data on pollution burden and population vulnerability in order to identify quote-unquote disadvantaged communities. And it's been used to guide investment compliance and enforcement activities across a range of programs, including sustainable development planning grants, allocating proceeds from greenhouse gas mitigation, the cap and trade program in our state, advancing renewable energy, and in things like permitting and enforcement of hazardous waste and air pollution permits. It's made up of indicators of pollution burden and population vulnerability, as I mentioned, which are listed here, and I won't get into the nitty-gritty details, but these are combined into a cumulative impact score that ranges from 0 to 100 and can be used to identify communities that are disproportionately burdened by environmental health hazards relative to other communities in the state. And unsurprisingly, given what I've shown you so far, the racial makeup of race is very correlated with this cumulative impact score. So on the left, try to get my pointer here. If you look at this topmost bar, this shows the first decile of Cal EnviroScreen score. These are the least impacted communities in this system. You want a lower score is better. You can see that 10% of the census tracts in the state fall into this category, and they're about 67% white, whereas the most impacted communities, the 10th decile down here, are the white population makes up only 9%, and you have much more diverse population in that group. And the average, this is the graph on the right, is a box plot where the middle line shows you the average or median cumulative impact score by race, and you could see that Latino, Black, and Pacific Islanders live in neighborhoods with higher cumulative impact scores relative to whites and also Native American and Asian populations. So this approach, as I said, has been used to guide investments, including climate change investments, where over $18 billion to date have been appropriated from our cap and trade program, our carbon trading program. And 35% of those revenues have to benefit disadvantaged populations as identified by the Cal EnviroScreen tool. And 20% have to be directly invested in those disadvantaged communities in programs like affordable housing, climate adaptation and resiliency, transit, public transportation, sustainable agriculture, etc. And this approach has served as a model for other statewide and national environmental justice screening tools, including federal ones that are now being used to direct climate investments in disadvantaged communities across the country as part of the Biden-Harris administration's Justice 40 initiative. The second tool I wanted to share relates to drinking water, and was produced through a community academic collaboration where we really sought to advance research and policy engagement on drinking water disparities in California. This was a partnership between the University of California, the California EPA Office of Environmental Health Hazard Assessment, and the Community Water Center, which is a nonprofit organization focused on water justice that works closely with communities to assure universal access to clean and affordable drinking water, and was instrumental in getting California's human right to water law passed. So California is the first state in the nation to legislatively recognize universal access to safe, clean, and affordable and accessible water as a human right. But although we did that over a decade ago, there are still nearly 1 million people that receive drinking water that does not meet regulatory health and safety standards in the state. And more than 1 million people that are not served by a water system, but instead rely on their own household domestic wells, which are unregulated and face additional risk to water security. An example of that is, often these are unincorporated communities, like Matheny Tract, which is a small farm worker community of about 1,500 people in the southern San Joaquin Valley that was founded by African Americans emigrating during the Dust Bowl. And as in other parts of the United States, Black migrants were met with Jim Crow style racism and could only settle on the outskirts of town and in cultivated farmland. Now the community is predominantly Latino farm workers, and it's served by a water system with 2 wells that have been in violation of the arsenic regulatory standard since 2010. And the neighboring city of Tulare refused to extend its pipes to Matheny, even after the state provided $5 million in funding to do so. And as a result, the state had to issue its first ever mandatory consolidation order to get cleaner water to Matheny by forcing the city of Tulare to extend its water provision into the neighboring community. Another example, and this is a quote from a reporter about how in the most prosperous state in the richest nation in the world, obtaining drinking water is still an everyday adventure. So these photos depict potable water delivery in the community of East Porterville after wells ran dry during the last major drought we had in California. So you can see people had to rely on emergency water deliveries during this time as hundreds of wells failed. So together in this project, we sought to, first of all, identify where are there communities served by domestic wells by combining information from the US Census, from drinking water well permits that had been issued by the state, residential tax parcels that could help us define exactly where people were living, particularly in these rural, not densely populated parts of the state. And to estimate, we also sought to estimate water quality in these areas, as well as within community drinking water systems. And we focused on 3 contaminants because they are common in California drinking water and because of the acute and chronic health risks associated with them. So we combined regulatory data from drinking water system test results mandated under the Clean Water Act. And then for the domestic well areas, we relied on groundwater samples in those areas to try to estimate people's water quality. And what we found is that, unsurprisingly, again, community water systems with higher proportions of residents being Latinx or other people of color had increased risk of drinking water with average concentrations, elevated concentrations of arsenic, nitrate, or hexavalent chromium. So for every 10% increase in the Latino population, for example, the risk of having drinking water with elevated concentrations of arsenic nitrate and hexavalent chromium above half the regulatory standard, the maximum contaminant level, increased by 14 to 31%, even after adjusting for region and accounting for spatial autocorrelation. And we saw the same thing amongst domestic well reliant communities with elevated risks of poor drinking water quality in communities where more people identified as Latino or other people of color. And these are prevalence ratios and confidence intervals that I'm showing you here. So, but the fact is most people don't even know where their drinking water comes from, let alone how safe it is. So we also sought to make this information available via a drinking water tool produced by the Community Water Center, available in English and Spanish. So on this site, you can look up your water provider, how your water quality compares to other parts of the state for 4 different contaminants. And so in this picture, example showing Los Angeles County, where we have about 200 water providers, and some of them highlighted here on this map have average concentrations of one contaminant of 1,2,3-trichloropropane, more than twice the regulatory standard. This is another example from the drinking water tool near Fresno, California, where on the left, we show the number of people that we estimated to be relying on domestic wells. In the middle, how many of those wells are likely to run dry under different drought scenarios that you can toggle between, because we are a drought-prone state. And right, average nitrate concentrations in groundwater in these areas. So we are continuing to refine this tool. It has been leveraged by advocates to help ensure, for example, that domestic well communities are accounted for in sustainable groundwater management plans. Some of the methods we developed also help to inform approaches taken by the state in their needs assessment to allocate millions of dollars from the Safe and Affordable Drinking Water Fund to systems that need help to help secure clean drinking water. And more recent updates to our tool include new information about potential sources of contamination and per and polyfluorinated alkyl substances, or PFAS forever chemicals. We're also building on this work by testing drinking water samples in households identified as high risk by this tool. And the last example I wanted to share is from a project called Toxic Tides. This work relates to sea level rise, hazardous sites, and environmental justice in California, and is motivated by the fact that we're expecting to see sea levels rise by about 3 feet by the end of this century if little is done to slow the pace of climate change. And in California, as well as many other parts of the country, our coastline is home to a lot of industrial facilities and military sites. When flooded, these sites can release toxic chemicals into air and floodwaters, potentially exposing nearby residents. So the goals of this project were to characterize the threats posed by sea level rise and the flooding of hazardous sites to socially disadvantaged populations, to again create an online mapping tool that helps visualize and make this information publicly accessible, and to share our findings with advocates and decision makers in order to help promote policies to protect vulnerable communities. And this was again a collaborative effort among academic researchers at the University of California and Climate Central, and community-based partners who are environmental justice and public health leaders from 5 nonprofit organizations. Very briefly, the way we went about this was to compile a list of hazardous site locations from 4 national administrative databases, and then to generate flood risk projections at these sites under different greenhouse gas emission scenarios and 2 time horizons, mid-century and end of century. And then to also layer onto that different metrics of population vulnerability derived from several different data sources, including the CalEnviroScreen tool that I shared earlier. And we found that over 400 sites in California are at risk of flooding at the end of the century, including, that is, if we continue to emit greenhouse gases at the pace we are now. And that includes things like power plants, sewage treatment plants, hazardous waste sites, refineries, and other industrial facilities, among others. We also found that if you live in a disadvantaged community, as defined by the CalEnviroScreen screening tool I shared earlier, you're 6 times more likely to reside within 1 kilometer of one of these at-risk sites. And the likelihood of living near an at-risk site was also higher in neighborhoods with lower voter turnout, higher poverty rates, more renters, more people of color, and more linguistically isolated households where no adults speak English. And we sought to make these results publicly available through an interactive website hosted on Climate Central's website, and also available in English and Spanish. And here you can zoom in, you can toggle between different flood risk thresholds, depending on your sort of level of risk aversion. You can select specific type of facilities that you're interested in. You can click on individual facilities to learn about its flood risk and other details about the site. You can toggle other settings, such as changing the different demographic indicators that are depicted in the background. And you can download all of the data and access it as well in Spanish, as is shown here. And we created sort of a county level, regional version to help facilitate more regional level planning. This tool was shared through a series of webinars with community residents, advocates, and policymakers, at which participants identified opportunities for policy action to prevent future toxic substances releases during flood events before they happen. And we've since expanded this analysis nationwide and plan to release a national website like the one I just showed you by the end of the year to make this information accessible in other parts of the country. And again, the idea here is that we have time to act because this is looking, again, at the end, slow moving sea level rise. So what can we do to ensure resilience in communities that host industrial sites along our coastlines? Each of these, particularly the last 2 tools that I shared, involved a collaborative research partnership process in which community-based partners were involved from the start to co-create the project goals and continued to provide feedback to the research team on an iterative basis. And this approach draws on principles of participatory and community engaged scholars, in which decision-making power related to the research process is shared between the scientific and community partners in recognition of the expertise that both contribute. And this approach helps ensure that the science we produce is more rigorous by reflecting on the ground realities that impacted communities are uniquely and intimately familiar with, and also more relevant to community concerns and active policy debates. And finally, that the work reaches a broader audience of stakeholders and decision makers, and thereby has a better chance of resulting in action that leads to improvements in community conditions. So I'm returning now to the question that I started with: how does the factory next door affect my health? And in sum, what I sought to convey through this talk is that, when we are approached with this question, it should also cause us to consider, why is this factory here in this particular community in the first place? And what structural factors resulted in this community living on the fence line of this factory? 2, what other environmental and social stressors is the community dealing with that could exacerbate the effects of this one particular factory, which on its own may not be that severe, but may contribute to cumulative impacts. And ultimately, how can we collaborate with impacted communities to generate actionable evidence that materially improves conditions on the ground? So with that, I will thank all of my many fantastic collaborators and funders. I have no conflicts of interest to declare, and I welcome your questions. Thanks.
Thank you. You have given us a lot of information and a lot to think about. And there are a number of questions that have been coming in. So let's work through as many of them as we can in the time that we have. I'll begin with a question that you addressed briefly in your talk and just invite you to elaborate a little bit. It's a question I think that gets raised a lot when we talk about disparities, and so that's I think it's worth sort of attending to it here. The question is, to what extent are the disparities that you described early in your presentation related to socioeconomic status as opposed to race, for example?
Thanks for that question. Yes, we have great racial disparities in income, particularly wealth, inherited wealth, and other aspects of socioeconomic status. So this is a understandable, logical question, right? But as I showed or tried to show with, and I know I zoomed through a lot of graphs and stuff, so I was trying to cover a lot and maybe didn't have time to explain each graph in enough detail, but one of the early graphs I showed with the blue equality line and the curves, tried to illustrate that the patterns are much more consistent in terms of race than they are in terms of income and other aspects of socioeconomic status. And that's been shown here in California, but also elsewhere. And in fact, there's several prominent examples of upper middle class African-American neighborhoods being targeted for landfills and other unwanted land uses. So it's not, I would say it's, the evidence suggests that racism has a lot more to do with it than classism per se, or just market forces or economic forces.
That even when we control for socioeconomic status, the disparities very much persist. The racial disparities very much persist. Yes. Yes. Yeah. So another attendee asks about sort of a reframing and what you might think about this, the idea of characterizing those communities that experience lesser degrees of burden as underburdened communities, as opposed to other communities being vulnerable or overly burdened. Could you comment on that framing and the extent to which it might help us to sort of shift our frame in thinking about sort of equity in sort of distribution of those burdens across communities?
Thanks for that great question. I mean, I think ultimately our goal is not to equalize things by increasing exposures in underburdened communities, right? Our goal is to improve conditions for everyone, particularly those that are overburdened. So I think there are increasingly some great examples of sort of mapping and identifying things like carbon footprints, right, of neighborhoods where, the drivers of climate change, greenhouse gases, and other polluting generating activities like it's very much tied to consumption, right? How much we pollute is tied to how much we consume. And of course, consumption is much higher among the wealthy. So there are mapping tools that look where the colors look exactly inverse to the one I showed, right? And are actually showing where consumption is the most rampant, and the environmental footprint or burden caused by that consumption, you know, where the people living in that neighborhood are driving a lot of this pollution. So I do think that type of approach is helpful in calling out the root causes of environmental degradation and how it is linked to consumption, and particularly consumption of the most privileged members of society. But I would not argue that, you know, we need to increase pollution in those neighborhoods in order to equalize things, but rather how do we live more sustainable lifestyles in general, and then how do we address these really persistent disparities in exposure and adverse health.
Thanks. I think that's a very helpful framing. Thank you. We have a few attendees who are raising questions about whether there are tools like the ones you described in your talk available in other states besides California. Are you able to sort of address what the options or resources are in other states as well?
Yeah, and I can share a few of these that can be shared with attendees after the talk. I know my talk was very California centric. I apologize for that. It's where most of my work is based. But there are several environmental justice screening tools available at the national level in the US, including the CDC has one, and the CGIS tool, which I'm going to get the acronym wrong, so I won't attempt it. But these, the CGIS is being used, as I said, to help direct funding through the Justice 40 initiative. So those are both available at the national level, and I can share those. And I know there are other states that have analogs to CalEnviroScreen. New Jersey has an environmental justice screening tool, and I'm sure there are many others that I may not be as familiar with. So I can definitely share those. Drinking water it's harder to get information on, actually, and California is one of the few states where we have a pretty good geographic boundaries of the service areas of drinking water providers. A lot of other states don't have that. So I'm not aware of a national analog. And the Toxic Tides Project, stay tuned. We'll be sharing a national tool. It includes Puerto Rico, Alaska, and Hawaii later this year. And I know there are international attendees on this webinar as well, so I wish I was more knowledgeable about what's out there at the international scale, and I'd be very curious to learn from others that may be familiar with that, but I don't have any resources at my fingertips to share for the international folks.
Thank you. Appreciate the additional resources. It's completely understandable that your talk was California centric, but it's helpful to have the additional resources, and we're happy to post them to the center website so that people can access them. I know you said during your talk that research is slow, but communities want and deserve action now. But we have an attendee who would like to know sort of what are the sort of most pressing additional empirical or data needs that we have now in terms of trying to move this work forward. Can you speak to that?
That's a great question. I think, I mean, one of the things I'm trying to work on now is, you know, how can we use these sort of cumulative impact methodologies and frameworks to assess progress over time, and are these investments working? So I think we're at that stage where it would, because disparities are not disappearing, and we are on the precipice of hopefully massive investments in things like solutions to the climate crisis. So there are many health co-benefits of addressing climate change. And if we can address the climate crisis with the urgency and resources that it warrants, it's a real opportunity to reduce environmental health disparities and remove some of these structural barriers and structural determinants. So I think metrics that can help us maximize the co-benefits of climate investments in marginalized communities and track progress towards joint social equity and sustainability goals over time could really help us there.
Thank you. Yeah, that makes a lot of sense. So the interventions that you have described focus really, and again, understandably, on sort of state investment, federal investment, enforcement of regulations, those sorts of things. We have some participants who are wondering about the role that either is taken or should be taken by industry. And I wonder if you could speak to that as well.
That's a great question. I mean, these are not problems that we can solve individually. They require
Right.
collective action, which is
Right.
why public policy is really needed. And I think, for most industries, there's not a huge incentive to address these issues, right? The incentive is profit and shareholder profits. So I think that's the challenge. Not to say there aren't great industries with triple bottom lines and a real mission of social responsibility. But ultimately, I think we need government action to create sustained change and accountability for industries that are more reluctant to change.
Thanks. We have a question about essentially what we can do. And this particular participant would like to know, how might public health professionals help build connections with urban planners and others, sort of build kind of interprofessional alliances or collaborations to help translate research findings into practices that reduce these types of health inequities. So this question is specifically about what can public health professionals do, but I just invite you to think about what can our audience, what are some takeaways in terms of what we can do to try to make things better.
Great question. I think there's a lot there. I think we all have something to contribute, whatever walk we're on in life. And I guess just in a general sense, things that address the root causes are the most fruitful, because the root causes of there are shared root causes of social inequality and environmental degradation. And as I said, we have an opportunity, an urgent need to address sustainability concerns and climate change. So how can we ensure that in our efforts to do that, we are dismantling and tackling social inequality? Because I don't think that that change will be durable unless we do that. So I know that's a really pie in the sky and tangible response. But I think, public health is in a perfect position to lead here with the public health approach. So I just invite, participants to rise to that challenge in whatever capacity they're working.
Thank you. That's a really beautiful place to end, I think. I'm afraid we're out of time. I wish we had time to get to all the questions, because obviously your talk has generated a lot of interest and a lot of questions. But let me just end by calling attention to our upcoming webinars. On April 12th, we'll have another ethics grand rounds with Dr. Angela Cade-Gepford and Dr. Ian Wolfe on developmental and ethical considerations in pediatric gender health, very timely topic. A lot of controversies about gender affirming care for kids lately. And then in May, we'll have a clinical ethics webinar, Unpacking Bedside Bioethics, on distinctions and controversies regarding withdrawing and withholding care at end of life. And we invite you to join us for those. Dr. Cushing, let me just end by thanking you. It's a really excellent presentation. Very appreciative of your work, and I am very grateful that you took the time to be with us today to share your expertise and lead us through this conversation.
Thank you. It's been my pleasure.